Hi, how are you? You all have a good lunch? Good, good. All right, so it's the afternoon. Let's get started. I'm going to be talking about machine learning in production. So this is TensorFlow Extended, or as it's popularly known, TFX. When we think about machine learning, we usually think about modeling. That's what research papers are written about. It's where the results are generated. That's usually what we think about. But when we move to a production environment, there are many other things that we need to think about that will influence how successful we are in delivering the results of our model to our customers or our users. And that's what we're talking about today. This is TensorFlow Extended. Google developed TensorFlow Extended because we needed it. Google does a lot of machine learning in production, and there was no platform available for us to use to put our machine learning models into production. So actually, TensorFlow Extended, TFX, was not the first platform that Google developed, but it is what we use now for all of Google and all of the alphabet companies. And it is what we are making available now to the rest of the world in open source. Some of our largest partners use TFX as well. So Airbnb, Twitter, PayPal. When you're doing machine learning in production, you have all the same issues and factors that you have for machine learning in any environment. If you're doing supervised learning, you need labeled data. You need to think about how well your data set covers your feature space. You need to think about things like rare conditions, especially for use cases like healthcare, where you may be trying to use machine learning in a condition that occurs rarely, but is very important. All of those are factors both when you're doing modeling and when you go to production. But for production, you also have to think about modern software development and all of the issues with taking a software solution, a software application, and putting it into production and maintaining it in production. So things like testability become very important. Scalability becomes very important. Just good software practice like modularity becomes very important. So this is a machine learning pipeline in a production environment, and this happens to be TFX, but any machine learning pipeline will be very similar. You will start and follow the process that you typically do in any machine learning development situation or inference usage. So you start by ingesting data, reading in data, and move through data wrangling, so validating the data, looking for problems, looking for anomalies, missing values, and then you're going to do feature engineering. And finally, you get to the part that you thought about at the beginning, training your model. From there, you need to validate the performance of your model. And performance in a production environment is not just the top level number. It's not just RMSE for the whole data set or cross entropy or what have you. It is individual parts of your data set because individual users only experience their part of your data set. There's also horizontal layers that become very important in a machine learning pipeline architecture. So orchestration is a key factor. Orchestration means creating and managing and maintaining your pipeline. as well as pipeline storage and the artifacts that you store in it, become very important, especially over the life cycle of a pipeline. Each of the pieces of a pipeline are referred to as components in the TFX architecture. This is what a component looks like. Two of the parts of a component, there are three there: the driver, the executor, and the publisher. Two of them are mostly boilerplate code. So they're code that you could change if you needed to, but you probably won't. Those are the driver and the publisher. The driver reads in data from your metadata store, and we'll talk about what the metadata store is. It provides that data to your executor. Your executor is where most of the work is done, and that is the part that you as a developer will interact with and code. The publisher takes the results of the executor and puts it back into your metadata store. So try to keep that picture in your head. We'll go through it and explain more about how this works. There is a configuration that each of your components will have. And for TFX, that configuration is written in Python, and it's very simple. It's often 1 or 2 lines of code. We'll take a look at what that looks like. And there is a metadata store for each of your components, well, for all of your components. Each of your components will write into and read from the metadata store. There's actually one exception. When you're ingesting data, that data comes from outside and not from the metadata store. So components read from and write to the metadata store. That's how data flows through the pipeline. So in this example, we have trainer who's writing a new model into metadata. We have model validator that's reading that new model, comparing it with the last one that was done, and then writing its result. And we have pusher that is taking that result. So I mentioned orchestration. Orchestration is how you define and operate a pipeline. And a very simple style of orchestration is task-aware, where you have a component that runs, and when it finishes, the result is passed to the next component in the pipeline. That works. That's fine. But it doesn't give you the same power as a task and data-aware pipeline. And we'll talk about why that's a more powerful architecture. But this is the architecture that TFX uses. So what's in the metadata store? What does it contain? Well, first of all, it contains data artifacts and the properties, the metadata, around those artifacts. So things like trained models or data that has passed through feature engineering or the schema for your features, what types are they? It also has a record of the runs of execution through the pipeline. Remember, we're in a production environment. So we run the pipeline, we start running it initially, and then we continue to run it 24/7. And as we do, we're getting new data coming into our business. We're training our new model. Our data is changing and evolving through time. So understanding how our model and our solution has changed over time is important. We also, when we're trying to understand the performance of our pipeline, it's often necessary to understand how data has flowed through it. So if I have a model that is not performing the way I would like it to, a key question is, what data was used to train that model? I want to look at that data and see if there are clues to why my model is not performing well, or maybe it's performing better than I thought it would. So the kinds of functionality that metadata gives you. First of all, the one we just talked about, finding out which data a model was trained on. Comparing the results for different model runs. I have a new model that I'm training today. How does it compare to the model I trained last week? Because last week, we weren't getting nearly the same performance. Why is that? Trying to understand that is an important part of a developer of a production pipeline. Carryover state. So I may have trained my model for 1,000 epochs, and I've looked at the results that I have, and it looks to me like maybe I should train it for 1,000 more. I don't want to start training from the beginning. I want to do a warm start and just continue from where I left off. And caching the results of previous component runs. If the input to a component did not change, then the output does not need to change. So I can cache that result, and the next time I need to run it, I can just pull that result from cache. I don't need to rerun that component. And remember, these components, if you have a lot of data, could take a long time to run. Orchestration. TFX is extendable in several ways. One of the ways is through orchestration. So the version that is in GitHub now supports 2 orchestrators out of the box, Kubeflow and Airflow, Apache Airflow. But if you have a different orchestrator that you want to use, maybe Argo or Celery, you can. So it's extendable in your choice of orchestrator. That's important in some cases. If you already have an orchestration environment that you use, we don't want to force you to use ours. You can just use yours and plug it into TFX. When you orchestrate a pipeline, this is what it looks like. A pipeline is a directed acyclic graph, or DAG. And this is what it looks like in 2 different orchestrators. It's the same DAG, just drawn slightly differently. So we'll go through the components and help you understand what's in the box. But keep in mind that you can add your own components. So this gets you started and certainly is a workable solution, but you may have other needs. First of all, we leverage Apache Beam quite heavily. Apache Beam is an abstraction layer on top of distributed pipeline frameworks. So things like Apache Flink or Apache Spark or Google Cloud Dataflow, those are distributed processing frameworks. Apache Beam runs on top of those and provides a stable, unified layer of abstraction on top of them. So when you decide to change frameworks, maybe you're going to go from Spark to Flink, you don't have to change your code. You just change the runner that Beam is going to use. So several of the components use Beam. And Beam, as I just said, runs on top of the distributed processing framework. In this example, Transform, one of the components, uses Beam. Other components, well, actually, one other component, well, sort of 2. One main one, anyway, uses just TensorFlow. And that's the trainer component. And it does what you typically think of when you think of machine learning. It trains a model. So that's what the trainer component does, and it's just TensorFlow. Other components really only need Python. So when you're pushing a model from production into a production target, really Python is enough. And when you have it all implemented, this is what it looks like. You read in data, you use the example gen component to convert it to TF record format. You use the stats gen component to create statistics across it that help you understand your data. Schema gen looks at the columns or types of your features and creates a schema that you can alter if you need to, but it's going to infer a schema and get you started. And then you're going to do feature engineering with transform and train your model with trainer and evaluate the results of your training with evaluator. And then decide, is my new model better than my old model? And if it is, I'll push it to production. And if it's not, I won't. And that's what Model Validator does. And finally, Pusher manages pushing your saved model to some deployment target. It could be one of several, it could be all of the above. So TensorFlow serving if you're going to a serving farm, TensorFlow Lite if you're going to a mobile application, or TensorFlow JS if you're going to a JavaScript or Node.js application, or TensorFlow Hub or if you're going to a repository or some other target. So each of the components has a configuration, and they each do separate things. They each do different things. We'll start at the beginning of the pipeline. Example gen reads in input, splits your data set into training and eval, and formats it as TF record. And the configuration is 2 lines of Python. It uses Apache Beam to do that. Remember, we're often working with large amounts of data, and a pipeline distributed processing framework like Beam is very useful. StatsGen calculates statistics. It does one epoch across your data and calculates statistics across it for things like the median of each feature or the standard deviation. This is typical data wrangling type of stuff. It's what you do normally in ML development. And we provide visualization tools which are very useful in the data wrangling process to help you understand the statistics of your data. So you want to look for things like that 6 o'clock hour there for the trip start hour where we don't have a lot of data. If I'm trying to do inference at 6 in the morning, I might not have the best results. So that's telling me, go get some more data for 6 a.m. Schema gen looks at your data and tries to infer the types. Do I have a float for each feature? Do I have an integer? Is it text? Is it categorical? What is it? If it's categorical, it's going to try to create a set of the valid categories that you can expect. Example validator takes the statistics and the schema, and it looks at your data and it tries to find problems. So it's going to look for anomalies in your data. It's going to look for missing values. It's going to look for values in features where the value is the wrong type. So this is, again, typical data wrangling types of stuff. Now, remember, this is in a production environment that you're running continuously. So you're doing this not just once to train an initial model, you're doing it every time you run the pipeline because your data changes. Transform is one of the components where the configuration, actually not the configuration, but the code is more complex. So you can see the configuration at the top is really just one line of Python, depending on how you want to count that. The code, however, can be arbitrarily complex because Transform is doing feature engineering. And you could have really quite complex feature engineering that you're doing. You may be creating a vocabulary from text data. You may be doing a lot of image augmentation. So I'm running out of time here. I'm going to speak a little faster, I'm afraid. Transform will create a transform graph. And that transform graph will be used for both training and serving. So we avoid the problem that is very typical in production environments where you're using one set of code in training and deploying to a different platform for production, and you hope that you're doing the same thing in both places. Transform eliminates that problem by using a graph that runs the same in training and in serving. Trainer trains your model. When it's done training your model, it creates two things: an eval saved graph, saved model rather, and a saved model. They're basically the same thing. The eval saved model has some extra information that is used in model analysis to analyze the performance of your model. You can use TensorBoard. Some of you are probably familiar with TensorBoard. Let me ask, who here is a TensorFlow developer? Who's used TensorFlow? Okay, a few of you. TensorBoard is a very powerful tool that you use to analyze the training process. So you look for things like overfitting, the typical things that you look for. A lot of times you would have been doing this in Seaborn or Matplotlib or something. You can also compare multiple training runs of a model. So if you trained a model last week, you can compare it to the model that you trained today and do it visually in TensorBoard. Evaluator is doing the model performance analysis, and it's doing it based on slices of your data. We'll look at an example of this in a bit. Model validator is making the decision based on criteria that you set up. Is this new model good enough to push to production, or should I leave the one that's currently running in production and try again on this new one? And pusher is what actually moves it to your deployment target, to production. So I'm going to look at an example of model understanding here. I moved over that fairly quickly. We have an example where we have a user, and this is hypothetical, who is selling online retail, and they're using their machine learning to try to help them understand click-through rates because they want to understand how much inventory to order. They don't want to order too much inventory because inventory is expensive, and they don't want to order too little because they need to have enough to satisfy orders. And then they discover that for a particular slice of their inventory, one part of their products, they have a problem. Men's dress shoes don't do nearly as well as they used to. Something changed. So why is it important to understand the performance of your model on individual slices like that? Because mispredictions have costs to your business. And the data you have is never the data, it's almost never the data that you wish you had. But the objective of your model is just a proxy for the actual business objective. We're using AUC as the model objective, but the real business objective is to minimize inventory cost. And finally, the real world doesn't stand still. Things change, and your model results will change. So we talk about something we call the ML Insights Triangle. When there's a problem, it's usually because some assumption was violated. But which one? Did the business change? Do you maybe have a new supplier of men's dress shoes and customers don't like it? Or has your data gone bad? Maybe your systems are giving you bad data and you're getting numbers that don't make sense. Or maybe your model needs to be changed, needs to be retrained, or maybe the architecture of your model needs to be changed. So where do you start? How do you solve problems? Well, you start with your data. You look for things like outliers. And we give you tools to help you do that. Visualization tools to look at your data and try to understand what's happening with your data set. The next thing probably to look at is model performance and understand how it performs on different slices of your data and how it compares this week to last month. And again, we give you tools to do that. Visualization tools to look at individual slices and combinations of slices of your data. We also give you what is called the what if tool. I'm running out of time. The what if tool is a very nice tool for doing exploration and experimentation with your data. But this is really what you need to focus on. Your model will never be perfect. If you've trained machine learning models, you know that. The question is, how much does it cost you to not be perfect? So this is really, on an ongoing basis, in a production environment, what is important. You can also look, just try to get more data or change your data set. And that's TFX. So I'm sorry I've gone over time here a little bit. I hope it was good for you, and thanks very much.
Thank you, Robert, for the talk. Thank you, Robert, for the talk. I have one question. Is the way that TFX is implemented at the moment, does it allow for like hybrid environment where part is on the cloud and part is like on-prem, or is that very difficult to do at the moment? So like one issue I have, in my own team is, some of our data for good and bad reasons need to stay inside our own IT department. But I would very much like to leverage as much as possible on a GCP. And it's not clear to me yet how much I can use some of those technologies in that kind of environment.
Yeah, so that's what we call a hybrid deployment, where you're running part of your pipeline on-prem and part of your pipeline in the cloud. That's an advanced deployment because, remember, we have this metadata store, and you're going to have to be able to access that from both environments. But there's certainly tools to be able to do that, and with the orchestrator, you'd probably end up using Airflow in that case. You could use, if you were running only on cloud, you could use Kubeflow. But in a hybrid environment, it's generally better to use Airflow or some other orchestrator.
I have a quick question. So some people in the audience, like David, have a long history with machine learning and can ask they have the context to ask a deep question. But maybe somebody here just attended the beginning TensorFlow, and they're working at their company just on a small scale with TensorFlow. But eventually they want to move into a pipeline type of production environment. What steps would you give to somebody who's more at the scientist level of machine learning to learn how to implement in more of a production pipeline?
So there's a couple of different questions there. Yeah. One is how as a beginner do you move from running in maybe a notebook into a production pipeline environment? Mm-hmm. The answer to that really is to try to understand what the pipeline requires. So understanding the basic overview that we just kind of talked about, and where the work that you do in your notebook would plug into that. So you're going to be doing in Python, you're going to be doing typical reading in your data, doing any transformations you need to do for feature engineering, doing your training. There's an analog for each of those in a pipeline. For the second part of your question, how does a researcher move into a pipeline? Researchers are often working with large data sets. And so, if you have a terabyte of data, you may be doing research, but you still need to worry about trying to, process that much data. And I would say start with a pipeline so that you have a good, capable framework to work with large data sets, if that's what you're doing.
Okay, thank you very much. Again, thank you, Robert.